This is Redox video 4. We're going to talk about how to balance a half reaction now. So first step, as always, is to assign oxidation numbers. So here Ag is +1, Ni is 0, Ni is +3, and Ag is 0. Next step, like we've been doing, is to identify what's oxidized and what's reduced. Remember, oxidation is loss of electrons, so we're going to become more positive. So that's going to be our nickel, which hopefully you can identify at this point. And what's reduced is the Ag +1 because it's gaining electrons or decreasing its oxidation number. It's going from +1 to 0. In the last video, we showed you how to write a half reaction for oxidation and reduction. So let's look at the half oxidation reaction. Okay, we have nickel is oxidized. So on the reactant side, nickel is 0. On the product side, nickel is +3. When you're oxidized, you're becoming more positive, and you need to put your electrons on the product side to balance it out. So we have one nickel. We're balanced in terms of mass. We now have to balance or have conservation of charge. So since my reactant has a charge of 0, my products have to have a charge of 0. So I'm going to add 3 electrons in here to balance out that +3 charge and make it equal to 0. So now I'm good with my half oxidation reaction. Now let's look at the half reduction reaction. We have silver is going from +1 to 0. We have conservation of mass. Let's have conservation of charge. So I'm going to add an electron. You could write +1 E-. You could just write E-. Now, we've talked about the fact that you can't have oxidation without reduction. They simultaneously occur at the same time. Something we have to add in now is that the number of electrons lost will always equal the number gained. So in this case, the nickel here is being oxidized. It's losing 3 electrons. You can't lose 3 electrons and only gain 1 in the reduction reaction. So what you're going to do is multiply the entire equation by a number that will make the number of electrons the same. So since I have 3 here, I'm going to multiply this whole equation by 3. So my new equation would become 3Ag +1 plus 3 electrons goes to 3Ag0. So that our number of electrons lost and gained are the same. We always want to make sure that they're the same. But now, if you actually were to look at this equation and balance it out in terms of mass and charge, it would be a little bit easier from the beginning if the equation was actually balanced. Sometimes you'll be given an equation and you'll be asked to determine how many moles would be needed if you had a different amount of moles. So I just want to go through the whole process of doing that. First, again, what we want to do is assign our oxidation numbers. So here, aluminum is 0, nickel is +2, aluminum is +3, and nickel is 0. If we look at what's oxidized, we could first decide that. Aluminum is going from 0 to +3, becoming more positive. So aluminum will be the one that's oxidized. The one that's reduced would be nickel. It's going from +2 to 0. We could write out our half oxidation and reduction reaction. So half oxidation would be, now you could do it with the coefficient or without. So aluminum goes from 0 to +3, and since it's oxidation, you're going to need 3 electrons. For the purpose of balancing, we're going to put in our coefficient just so that we could help to see that the reaction will actually balance if we have that in there. So aluminum goes from 0 to 2Al +3. Since I'm balanced in terms of mass, 2 and 2, I'm good. Now we have to look at the charge. 2 times 3 is +6, so I need 6 electrons over here. Let's look at the half reduction reaction. Well, when we're reduced, nickel is going from +2 to 0. So I have to add in over here, I didn't leave myself in a frame, but 2 electrons. So I need 2 electrons plus the Ni +2 will give me the reduction half reaction. If we look at the initial state, see how I have 2 electrons here and 3? You would have to balance it out. But if you just use the coefficients from the equation, you won't really have to worry about balancing. So now if we look at the coefficients, for nickel, we have 3Ni +2 goes to 3Ni0. I'm balanced in terms of mass. And now the charge, I'd have to have 6 electrons. So when you use the coefficients, like in this example, the number of electrons lost and gained are going to be the same. If I just said write a half oxidation reaction, I would take this one. Or if we just said write a reduction half reaction, we would take this. But if they're asking you to balance the overall reaction and make sure that the mass and charge are equal, then we have to look at what the coefficients are. Something else you could be asked is looking at the number of moles. So what if I said I had 9 moles of nickel? I'm going to take this away so it clears this up. So if I had 9 moles of nickel plus 2 ions, how many moles of aluminum would be needed? So right now, I have 3 moles of nickel plus 2. They're giving you moles. How many moles? This is a mole-mole ratio. Remember, to do a mole-mole ratio, we're just going to incorporate now into redox. You have 9 moles of nickel plus 2. Find nickel plus 2. It's right here. Put a 9 on top. How many moles of Al solid? Find the Al solid. Put an X on top. We want to know how many we would need. And you're just going to do a mole-to-mole ratio. So your setup would be 9 over 3 equals X over 2. You would cross multiply. 10 equals 3X. X equals 6. So they're going to do mole-mole ratio in this redox chapter, where they could ask you, based on the balanced equation, because now we're going to have balanced equations again in the redox form, how many moles would be needed if they change the amount of moles. So again, if it's mole-mole, just put it on top and make a proportion for whatever they're asking for.